Hi everybody. Watch this. I'm going to tell you about the law of cosines. First, just let me write out what is the law of cosines and give you a little idea about what you could use it for. Let's look at this triangle ABC, and opposite angle A, we're going to call that side little a, like we ought to do, and opposite angle B, yep, that's side little b, and there's side little c. Let's say we knew this length and we knew this length. They were given to us. It might have been 6 and 10, or it might have been anything, and we also knew this angle. When you know a side, an angle, and a side, that's the time that you would use the law of cosines. We could find this length, and I'm going to write out the law of cosines right here. C squared would equal, and it starts off like the Pythagorean theorem, a squared plus b squared minus, to get this length, that length squared will equal this one squared plus this one squared minus 2 times a times b times the cosine of that angle C. That, my friends, is the law of cosines. Not quite as pretty as the law of sines and a little bit harder to memorize, but you're going to want to memorize that one. And then let's use it to do a couple of things. We're going to find a couple of lengths. Use the law of cosine to find these couple of lengths. And in this figure, I guess I'm looking for this side little a, huh? We could have done this with any of these three angles, but this time we're pretty much forced to use this 42-degree angle. And here's how you use the law of cosines. We'll start off with the thing that I desire, that's a, and we begin with a squared will equal 12 squared plus 16 squared just as it began before, minus 2 times 12 times 16 times the cosine of the included angle, 42 degrees. I think we ought to write that out, and then we'll calculate it. And I got a calculator handy that I think you can witness with. And let's just type this in and see that we can get the things we're expecting to get. So you should begin with, and you should do this too, 12 squared plus, let me get so I can see it, 16 squared minus 2 times 12 times 16 cosine of that included angle, 42. And interestingly, when you get that, that is the square of the answer. That is a squared. A squared is 114.632. 114.6, but I don't really care about that so much. What I really want to know is what's the length for A. So I got to take the square root of that amount. That is the square of the answer. Lots of times on tests, kids come running to my desk and say, I'm doing this wrong. I'm getting this length that's great big. Well, you got the square of the answer, that 114.6. So we'll take the square root of that amount, and that ought to have been about 10.7, huh? And I think that's a fitting answer here, that this length would have been 10.7. We don't know any other angle measures, but we will in a minute. We'll work some more out. Let's look at this guy too. And we're just looking for lengths. That's all I'm doing for the moment. And the only length I don't know is this side here, little r, huh? And I can use, we have that same side, angle, side relationship, and that's when you would use the law of sines. Excuse me. That's when you would use the law of cosines. R squared will equal, working off of this angle, 20 squared plus 12 squared minus 2 times 20 times 12 times the cosine of the included angle at 100 degrees. Very powerful tool, the law of cosines. We're going to have to evaluate that stuff. You should too. 20 squared plus 12 squared minus 2 times 20 times 12 cosine 100. Ooh, I do have an error there, but I think I can fix that if I delete that. Minus 2 times 20 times 12 cosine of the included angle 100. I think that's all good. Maybe you can agree with that. And then when I hit that should be the square of the answer. That is not the answer. I'll take the square root of that. I'm thinking about 25, huh? If I was going to round out to the nearest tenth, we have to call R 25. And I think that could be Pretty good thing here. Certainly that is the biggest of the three sides, and it's opposite to the largest of the three angles too. So you've seen a little bit of how we can use the law of cosines to find the length when you have a side-angle-side relationship. Both of these have that circumstance. But you can also adapt the law of cosines to find the measure of an angle. Let me just decorate this triangle for a second. I'm going to call this side little a, and opposite angle b, call that one side little b, and their side little c. And I could go for any of the three angles. I'm going to say, what if I want to know about angle A? And then we'll find all three angles of a triangle. But right now I'm going to go for the measure of angle A with the adapted law of cosines. Here's how that would look. The cosine of angle A would equal this one squared, b squared, plus c squared minus a squared, all over 2 times b times c. Actually, this comes from, and we ought to do it in class, the law of cosines. I just solved this equation for the cosine of angle C. Or in this case, for the cosine of angle A, but there's the formula right there. So we have to evaluate this. And then we got to work to arc cosine that to get the answer that we'll care about. But that's just the general expression right here. But now, let's put that to work on this last triangle. Here I'm given the three sides of a triangle, and I don't know any of the angles. What would you do if you needed to know the measures of these angles? Let's go for angle A first. And I'm going to use the law of cosines 3 times in a row. It may get kind of big and cumbersome, but we're going to find the measures of all three of those angles. If I were looking for angle A first, the cosine of angle A should equal, and you work with the adjacent sides first, 25 squared plus 18 squared minus the far away one, 12 squared, over 2 times 25 times 18. We're going to get that, then we're going to arc cosine it, and we're going to know the measure of angle A. Let's make that happen. Clear all the junk and going with this angle A. Keep this handy. I want you to be able to see it if you could. 25 squared. Actually, I'm going to lead with parentheses here. 25 squared. I'm sorry. 25 squared plus 18 squared minus 12 squared. Close those parentheses, and then the whole thing is going to be divided by, and then I'm going to put parentheses around this denominator as well. Just put parentheses there and there. Therefore, this whole thing is going to be divided by this whole product right here, divided by 2 times 25 times 18. And I get this number. Let me go ahead and write that down, that the cosine of angle A is equal to 0.8944. But I want to know the measure of angle A. So what should I do with this to get the measure of angle A? Yeah, I better arc cosine it, huh? I'm going to do it with the number that I have right here. It'll be a little more accurate. So if I go second cosine of that amount, you could type in the 0.8944, that would have been okay. That tells me that angle should have been 26.6 degrees, close as I can get. 26.6 degrees. Hold that thought. Let's get some more practice. Let's go for angle C this time. Let's go for angle C this time. And you're going to use the law of cosines to do this. Actually, once we found that angle right there to be 26.6 degrees, I could use the law of sines to do other things. I just want to practice with the law of cosines. I could find the measures of the angles using the law of sines, but I just want to practice with the law of cosines and get that across. So let me just start by saying the cosine of angle C should equal 12 squared plus 25 squared minus the far away one squared, 18 squared, over 2 times 12 times 25. We should evaluate that amount right there. Let's get what that is. And then we're going to arc cosine that amount, and we'll know the measure of angle C. I expect angle C to be bigger than this angle because it's opposite a bigger side. Let's see what comes up here. I'm going to leave with parentheses, as I should. 12 squared plus 25 squared minus 18 squared. Close those parentheses and divide by parentheses around the denominator as well. 2 times 12 times 25. And I have this decimal amount, 0.7417. 7417. I should arc cosine that amount. The arc cosine of 0.7417, that'll be the measured angle C. I already have that number on my calculator. I'm just going to go second cosine that amount. And that tells me that angle should be 42.1 degrees, huh? Hold that thought. 42.1 degrees. So, and being as the angle C should be larger than angle A because it's opposite a bigger side. Now this angle B looks like it's obtuse to me, and I think it's going to have to be obtuse. Let's just see. Let's set it up to find the measure of angle B by using the law of cosines. So you'll begin by writing the cosine angle B equals. And with this, first two squares are going to be the adjacent sides. That's 18 squared plus 12 squared minus the far away guy, 25 squared, all over 2 times the 18 times 12. You got to work this a few times, then it gets easier to do. We're going to get that number, then we're going to arc cosine that amount. Let me go ahead and write that out. I'll go arc cosine whatever this decimal amount is coming out of that fraction right there. That's going to require a calculator for sure. Let's make that happen. 18 squared plus 12 squared minus 25 squared. I didn't put parentheses around that time, and that's really okay if I just hit enter and then divide by, and I do want parentheses around the denominator, 2 times 18 times 12 times 18 times 12. And that way I could put the whole answer to that negative 157 divided by this gives me this amount right there. And there I have a negative, don't I? Negative 0.3634. Let's arc cosine that amount, and we'll know the measure of angle B. And then we'll check them, see if they add up to 180, and I'm hoping that they do. I expect that they would. I have that number on my calculator, but you could type it in as you need to. I'm going to go second cosine of that amount. And that angle has to be 111.3 degrees, huh? 111.3 degrees. Now this is just an arbitrary triangle. I just made it up, but I'm thinking it came out pretty good. Let's add up those angles and see if they do what they're supposed to do. 26.6 was one of them, plus the other guy was 42.1. Plus 111.3. And lo and behold, they do add up to 180. Now, I know sometimes when you're doing this stuff, there'll be a rounding error, and it may add up to 179.8 or 181 point something, 180.3. And we may have some small errors. I want to show you another question. I think it's a kind of a good one. As we study the law of cosines, let me just set up a problem. Let's say that this is Galveston Island. You might draw that picture too. That's the east end of Galveston Island. That's off its bayou, and there's the island itself. And you went fishing one day. You left the east end of Galveston Island, and you motored straight out there. Actually, let's say that's an angle of, making this up, 47 degrees with the coastline. You're fishing with me, and I brought my protractor. And we took off at an angle of 47 degrees with the coastline of the beach, and we motored for, let's say, 40 miles. And then our boat breaks down, and we're out here broke down. And we have to know the length of Galveston Island, and I'm going to say Galveston Island is 28 miles long. So we broke down out here, but with your cell phone, you were able to raise a friend who lives on the west end of Galveston Island. He said, well, I'll come get you with your broke down boat. I'll tow you back to the beach. But you're going to have to tell me how far it is and what angle. We have to find that distance right there. The guy at San Luis Pass says, if you tell me the distance to your boat, then I can probably come get you. And you might see that this is a beautiful example of how we could use the law of cosines. Good thing you brought your calculator when you went fishing, huh? Let's write out that formula for how we get that distance. And the distance squared would equal 28 squared plus 40 squared minus 2 times 28 times 40 times the cosine of the included angle, and that angle was 47 degrees. Huh? We're just finding a length this time. Interestingly, it's going to give me the square of that distance first, and then I'll take the square root and we'll know the distance itself. So just hit that with a calculator, getting a little practice. 28 squared. Well, I didn't do that well. 28 squared plus 40 squared minus 2 times 28 times 40 cosine of 47. Yeah, I think that's all good. Enter that, and there's the square of the answer. Distance squared is 856, which I really don't care much about. Just write it this time, 0.3. Then I'll take the square root of that, and I'll know the distance itself. Take the square root of that amount. And that would make it be, right, you tell your friend we're 29.26 miles from the beach. That's how far he's got to come. And then you could also, since this distance is 29.26, and he said, well, I got to know that angle too. He's also got a protractor, being a student of geometry. He says, if you tell me that angle, I know I can go 29.26 miles out there, but how are we going to get that angle? And actually, you could use the law of sines, and you could use the law of cosines. You could do either one. Just as we're practicing the law of cosines right now. Let's do it both ways, but let's do it with the law of cosines first. What would you say about the cosine of alpha? Let's use the adjacent sides first. That would be 28 squared plus 29.26 squared minus the far away guy, minus 40 squared over 2 times 28 times 29.26. Let's get that number. Get that decimal amount, then we'll arc cosine it. I guess I'll write that cosine of alpha will equal, we're going to get some decimal number from that, then we'll arc cosine it. So with a calculator, coming along, I need to leave with parentheses, don't I? 28 squared plus 29.26 squared minus 40 squared. Close those parentheses, divided by, and the parentheses around the denominator too. 2 times 28 times 29.26. Okay, there's, I'm going to hit enter, and I got that number. That is the cosine of the angle that I care about. I'll write that down. Cosine of this is equal to 0.0245. 0.0245. So I could type that in, that'd be okay, but I'm going to hit it with this right here and go second cosine that amount. And that tells me to be about 88.6 degrees. What if I would have done it with this? If I'd gone second cosine of just that 0.0245. And that still would have kept it 88.59. So we're okay with either one of those. You didn't need to keep the long number. That tells me that alpha would have been 88.6 degrees. So that's a pretty steep angle for there. But now, what if you'd done it with the law of sines? Let's hit this with the law of sines, and I think it would have been a little quicker and easier, but one thing to see. Hitting it with the law of sines, the sine of 47 is to the length of its opposing side, 29.26. As, going for this angle this time, as the sine of alpha is to the length of its opposing side, 40. So what are you going to do with this proportion, huh? Now we're going to solve it for the sine of angle alpha, huh? I'm going to write that out, I guess. The sine of alpha will be 40 times the sine of 47 over 29.26. Let's get that number with our calculator. That'll be the sine of alpha. Then we'll arc sine whatever we find right there. Let me write that out though. The sine of alpha is, get that amount with my calculator. I'm going to lead with parentheses, 40 sine 47 divided by 29.26. Oh, I don't need that parentheses there. I'll hit enter, and there I got this amount, but what am I going to do with that amount? It's 0.999 something. That's the sine of the angle, so I should arc sine that amount, shouldn't I? Sine of alpha was 0.9998. Let's arc sine that amount, second sine that amount. And there it is, being 88.85, huh? A little bit off. We're off by 1/10 of a degree. 88.85. Oh, we're off by a little bit more than that, huh? 88.